Hello everyone, hope you are enjoying good health and happy life. I am Mohammed Asif. In the previous lecture, we have started our new chapter, Energy from Chemicals. And in the first video, we discussed exo and endothermic processes and their energy profile diagram, how we can guess either the process is exo or endo, or how it can be represented graphically. Now, in this video, we will discuss the nature of the process with respect to bond making and bond breaking. For example, if I want to explain this, for example, if I have a 2-bar magnet, and if I put both these magnet with opposite ends very close to each other, then whenever both of them will enter into their magnetic field, what will happen? Both of them will combine immediately due to the force of attraction. Now, will both of these magnets will be separated themselves? No. The answer is no. If we want to separate both of these magnets, what we should do, we have to work done and we have to apply energy to separate them. Why we have to apply energy to separate? It means that when both of these magnets attract each other, due to their force of attraction, some amount of energy has been lost. Now, if we provide the same amount of lost energy again to both of these magnets, then both of these will be separated out. Now, from this point, we can explain two things quite easily. One thing, it means that whenever force of attraction will be created between particles, then it is clear that energy of the particles will be decreased. Energy will be decreased. Now, if the energy is decreasing of particles, then where the energy is going, it means that the energy is going away from the particles. Means this is the good example of exothermic reaction. Now, from this, we can conclude that bond making is always exothermic process because force of attraction is created between particles. Now, if we take 2-bar magnet, but the same end, North Pole versus North Pole or South Pole versus South Pole, we try to take both of these magnets very close to each other, what will happen? There will be a force of repulsion. They will not combine together. And if we leave them, both of these magnets will be separated automatically. Why? Because when we try to keep the both magnets very close to each other, due to repulsion, their energy is increased. And when we left the both magnet, due to that increased energy, both of the magnets become apart from each other. It means that whenever force of repulsion will be created between particles, then energy of the particle will increase. And in this manner, this process will be considered as an endothermic process. So, in case of bond making and bond breaking, remember, bond making or bond forming is always exothermic process. Exothermic process. And bond breaking. Bond breaking is endothermic process. Endothermic process. Remember, this is the most important. Keep in mind, bond forming is always exothermic reaction. Why? Because whenever bond will be formed, force of attraction will be created and energy will be decreased, and exothermic process takes place. And if we break a bond, we have to provide energy. That's why the process will be called as endothermic process. Now, using bond energy values given in the booklet, we can easily calculate either the reaction taking place is exo or endo. For example, if we react hydrogen with oxygen molecule, oxygen, double bond of oxygen, what will happen? As a result, we will get two molecule of water. Two molecule of water. Now, if we know that what are the bond energies of the reactants and what are the bond energies of the products, we can easily decide either the process will be exo or endo. Remember, for example, if the bond energy of hydrogen is 436, then it means that 436 multiplied by 2, because two bonds are going to be break. Plus, if the bond energy of oxygen is for example bond energies values can be taken from 496. 496. It means that 496 multiplied by 1. Then, if we look at the product side, 4 bonds are formed. 4 bonds. This is oxygen and this is hydrogen. If one bond of oxygen hydrogen is 463, for example, if one bond is 463, then how many bonds are formed? These are from 4 bonds in case of products. If we multiply and then add, what we will get 12, 7, 8 plus 4, 9, 6, total 8. 16 and 1368 kilojoule energy. This is the energy of these reactants. How many energy in product side? 1852 kilojoules. This much amount is of product. Now, according to the definition, this much amount of energy is released, and this much amount of energy is absorbed, because here in reactant sides bonds are going to be break. This much amount of energy is absorbed, and on product side, as new bonds are going to form, this much amount of energy is released. Now, if we check the difference, we use the formula for this purpose. That formula is change in enthalpy, reactants energy minus products energy. Now, if we apply this formula, what we will get? 1368 minus 1852. What will be the answer? The answer will be minus 484 kilojoule. This much amount of energy is extra released when these molecules of hydrogen, two molecules of hydrogen according to the Balanced chemical equation, react with 1 mole of oxygen producing 2 mole of water. This much amount of energy will be released. Now this negative sign is indicating that the process is exothermic. This negative sign is indicating the process is exothermic. It means that in this process, energy of the reactants are larger, while the energy of the product will be lesser, because large amount of energy has been released. Here in case of reactants, the amount of energy is larger because lesser amount of energy is required to break all these reactant bonds. Now, as I have already told that the bond energy 496 for 1 mole of oxygen, actually this is the energy of activation for the oxygen molecule. Similarly, 436, which is the bond energy of hydrogen, actually this is the energy of activation for the hydrogen molecule. If we put both of these gases, hydrogen and oxygen, in a closed container, we shake it very well, both of these will not react, because at a normal conditions of temperature and pressure, the kinetic energy of the oxygen and kinetic energy of the hydrogen molecule is not too much, that as a result of their collision, they produce energy equal to the bond energy of the molecule. So these bonds will not be broken easily. Then how this happens? We provide a naked flame, we provide high temperature. It means that whenever we will provide temperature, actually we are increasing the energy of the reacting molecule equal to the energy of activation. Whenever their energy will become equal to the energy of activation, then both of these reactants will react together and easily transform into the products. The energy profile diagram for such processes we have already discussed. This is the time axis and this is the energy. In case of this particular reaction, such type of graph will be formed. These are the reactants and this is the product. Now, this much amount of energy is energy of activation and this much amount of energy is enthalpy change, which is given out. It means that now, when we provide naked flame or high temperature, energy of the reactant increases, and when it comes equal to the energy of activation, then reactant change suddenly into the products. This is the effect of temperature. Now there is effect of catalyst also. In so many reactions, we add small amount of another substance which speed up a chemical reaction. That particular substance which speed up the rate of a chemical reaction, that is called as catalyst. For example, enzymes are also biological catalyst, and in case of inorganic chemistry, so many catalysts we use. For example, in case of hydrogenation in the manufacturing of margarine, we use nickel as a catalyst. What nickel will do? That will decrease the energy of activation. Whenever we will add catalyst, a new pathway will form, which will lower the energy of activation. Catalyst will decrease the energy of activation. That's why reactants can easily cross the energy barrier of energy activation, and the reactant will automatically change into the product. That's why catalyst will also speed up the chemical reaction. In case of uncatalyzed, more amount of energy or more time will be required, but if we use catalyst, it means that in a lesser time and with lesser amount of energy, we can perform the same chemical reaction. It means that such catalyst save our time and also save money. As a result, the reaction is performed quite easily using a catalyst. Now, in this manner, comparing energies absorbed by the reactants and energies given out during the product formation, we can easily calculate either the process is exo or endo on the basis of these. Now, one thing more important is, remember all bonds are of two types. One are called polar bonds, and second is called non-polar bonds. Now, polar bonds are stronger than non-polar bonds. Example, if I burn carbon in oxygen gas. Now, if this is a pure carbon coal, then all bonds are made between carbon, and all these bonds are non-polar bond. The double bond present between oxygen molecule is also non-polar bond because both of the atoms are same with zero difference of electronegativity. When reaction will take place, what will happen? Carbon dioxide will form, CO2, this will form. Now, carbon dioxide molecule, no doubt, this molecule itself is non-polar, but the bond formed are polar. Bond formed are negative, partial positive, partial negative. Now, overall dipole moment of carbon dioxide 0. That's why the overall molecule is non-polar. But remember, the bond between carbon and oxygen is polar, and due to this polar nature, as these are stronger bonds are going to form, that's why more amount of energy will be released and lesser amount of energy will be absorbed to break all these bonds. Automatically, what will happen? Such type of the processes in which non-polar bond breaks and polar bond form, these are always exothermic. These are always exothermic. Always exothermic. In other words, all those reactions in which oxygen gas take part as a reactant all those reactions are exothermic, always. These includes respiration, burning, or oxidation of any other substance. For example, if we have alcohol, if we perform oxidation of alcohol to convert it into carboxylic acid, for example, if we convert this C2H5OH into carboxylic acid by adding K2Cr2O7 and H2SO4, what will happen? This will convert into CH3COOH. This is the oxidation process. This is the burning process. So all those processes in which oxygen take part as a reactant, those are all examples of exothermic reactions. And all these are exothermic. Whenever polar bond break and non-polar bond form, then endothermic process will take place. And whenever non-polar bond breaks and polar bonds are formed, then exothermic reaction will take place. Now, what are the endothermic? Examples of endothermic are thermal decomposition. Thermal decomposition of all substances, are endothermic. All are endothermic. That's why in case of thermal decomposition, we can check. For example, in case of thermal decomposition, if we take calcium carbonate, if we strongly heat this will be changed into calcium oxide and carbon dioxide. Similarly, if we take magnesium hydroxide, heat it will change into magnesium oxide plus water. For example, similarly, if we have magnesium nitrate, if we heat it, what will happen? All of these will change: magnesium oxide, nitrogen dioxide and oxygen. The equation you can balance yourself. All these processes, because all of these processes are taking place on absorption of heat energy, that's why all these are the examples of endothermic processes. Now, my dear students, I have explained exo and endothermic process with respect to bond making and bond breaking process. Using the particular formula, we can judge either the process is exo or endo. I hope you have understood all these concepts. In case of any problem, you can contact the Study of Change page.